Okay, chapter 8, lesson 2. This lesson talks about volume of a cone. So in 8.1, we talked about the volume of a cylinder, and a cylinder and a cone are related. Let's see, get the pen here. If I were to take this and extend this up, and do something like that. I know, you're impressed by my artistic abilities, aren't you? I knew it. I could tell. Anyway, so you'd make a cylinder. Notice that it has the same base, right? Same circle, same height as this cylinder, except for you don't have all of the volume, do you? You don't have all of that space. You just have basically this part in the middle, but you don't have this section over here, and you don't have this section over here. And because this is 2D representation of a 3D figure, you actually have stuff on the front and on the back. So here's what happens. If I were to take this cone right here, and let's say it had a hole in the bottom and I could fill it up with water, and then I could dump it into the same cylinder that has the same size base and is the same height, it would actually take 3 of them. It would take 3 cones to fill the cylinder. So if I want to know just the volume of the cylinder, well, we learned that in 8.1, area of the base times the height. So pi times radius squared times the height. But if I just want to know the cone, I still find the volume of the cylinder, pi times radius squared times the height. But if I only want the cone, I only want 1/3 of it. So I would take that and either multiply it by 1/3 or divide it by 3, whichever way you'd like to think of it. All right, let's practice with this a little bit on example 1. I promise this lesson will be a lot shorter than 8.1. That was a little ridiculous, don't you think? So I promised I'd make it up to you on this one, and here we go. So find the volume of the cone round to the nearest tenth. So area of the base, pi times radius squared. So 3.14 times the radius, which is 3, squared times the height. So 3.14 times 9 times 6. 3.14 times 9, which is 3 squared, times the height, which is 6. I get 169.56. But again, it's a cone. It's 1/3 of that cylinder. So we just use a cylinder formula. So to make it work for a cone, we have to divide it by 3. 56.52 rounded to the nearest tenth, 56.5. Okay. Should be easy. Should be an easy lesson for you. It's just one more step than what we did before. So if you got 8.1, this one should be a breeze for you. So I want you to pause it and try A and B, please. Okay, back with me. Let's talk about A. Area of the base times the height divided by 3. So 3.14 times 2 squared, pi times radius squared, times the height, whatever we get, divided by 3. That should give us, rounded to the nearest tenth, should give us, if we leave pi as pi, 29.3. Remember, our label is cubic because it is volume, 29.3 feet cubed. This one, the diameter is 24. Our formula doesn't use the diameter, it uses the radius. So we take half of it. So we want pi times 12 squared times the height. Now the height could be a little confusing. The height is not 24. You'd have to set it on its base, which is a circle. So the height is actually 26. So I've got 3.14, and just for our calculator's purposes, 3.14 we're going to use for pi. You may use the pi button if you wish. 3.14 times 12 squared is 12 times 12, which is 144, times the height, which is 26. Now that gives us the whole thing. We only want the cone. Divide by 3. 3,918.7 if you're using 3.14. If you're using the pi button, you probably got 3,920.7. So I'm going to go ahead and write that over here. 3,920.7 millimeters cubed. Okay? Again, I will take that answer or this one. Just depends on if your calculator has a pi button or if you use 3.14. Both are equally correct. Okay, let's move on to number 2. A cone-shaped paper cup is filled with water. The height of the cup is 10 centimeters. The diameter is 8 centimeters. What is the volume of the paper cup? So you're looking for the volume, the space inside. That paper cup there is a cone. So it's the same thing. We're going to take area of the base. The diameter is 8, so the diameter that we need, the radius that we need is 4. So pi times radius squared times the height, and it tells you that the height is 10. All right, and whatever you get, divide it by 3. So I'm looking at 3.14 times 4 times 4 times 10 divided by 3. 167.5 rounded off. They used pi as pi, so they got 167.6. Acceptable to me. Make sure you are putting cubic centimeters or centimeters cubed. Either way you want to do it at the end of that. Okay. Let's go on and have you try the next one. And again, I hope you actually pause these and try it whenever I say pause and try it, just so that way you can get yourself used to using these. Okay, April is filling 6 identical cones for her piñata. Each cone has a radius of 1.5 inches and a height of 9 inches. What is the total volume of the cones? Round to the nearest tenth. So, 6 identical cones. Let's find the volume of one of those cones. So, pi times radius squared. Radius is 1.5. So 1.5 times 1.5 times the height. The height is 9. So let's do that out. Move this out of my way. 3.14 times 1.5 times 1.5 times 9. What is that? Yeah, 63.585, but what does that represent? That would be the volume of the entire cylinder if we so, that's not a pretty circle, if we so wish to use it. Right, but we don't want the cylinder. We want that crazy cone that's just in the middle that takes up 1/3 the area. So we're going to take 63.585 divided by 3. 21.195. 21.195. Oh no, you're supposed to round to the nearest tenth. Well, you are when you're done. We're not done. That's the volume of one of them. And it says she's making 6. Right? And it wants to know what is the total volume of the cones. Total volumes of the cones, which means you need to times this answer, 21.195, times 6, since there's 6 identical cones. I get 127.2. And what was our label? Inches cubed. 127.2 inches cubed. All right, last one here before I promise I'd get you out of here short today. Well, anything short compared to yesterday's, right? All right, volume of composite solids. This is no different than before, except for now you've got cones and cylinders on top of each other. So, for example, one here, find the volume of the solid round to the nearest tenth. You're going to find the volume of that cylinder, find the volume of that cone. Notice that they have the same base. So you really only have to find the base once. And then just take it by the respective heights, which are different. So find the volume of the cylinder. I have pi times radius squared. Radius is 8. So 3.14 times 4 times 4. That's going to give you the area of this base right here, which you will use for both. So 3.14 times 4 times 4. To get the volume of the cylinder, we're going to take this times 4, which is the height, and it tells you that right there. Volume of the cylinder, right here. So for the cone, we're going to use the same thing, 3.14 times 4 times 4. That's a 4, not a y. But this time we're going to take it times 5 because that's the height of the cone. And whatever we get, we have to divide by 3. So the same base that we used before, 3.14 times 4 times 4 times 5, because the cone is 5 tall. And we're dividing by 3 because, in fact, it is a cone. 83.8, put those together, voila, 284.9 cubic feet. Okay, I think we are going to stop there. I think you've got it. You've listened to me enough over the last couple days. So practice with those. Come see me with questions. Good luck.